Right, so let me show you some example on how to sketch functions. Let's start with the easiest one, which is going to be a linear function. I have f of x is equal to 3x minus 1. And judging from the case that this is to the power of 1, we know that this is going to be a linear function. And we know that the graph of a linear function is going to be a straight line. And when you want to find a graph of linear function, remember I listed over here, there are two things that you have to find, the y-intercept and also the x-intercept. And for this case, from the function itself, there are two informations that we know. First, the value of the gradient, m is going to equal 3. So what information do we know about that? That your graph is supposed to be increasing. And here you have a c value equal -1. And c value actually gives you the y-intercept. So therefore, your graph is going to intercept the y is going to be f of x axis for this case. The f of x axis at -1. And we need to find another one component, which is going to be the x-intercept. Okay, so when do we have the x-intercept? So that happen when y is equal 0. Because, okay, so this is going to be the case. For example, this is where my intercept is. So this intercept happen when my value of y is equal 0. So that's why I'm going to substitute y equals 0 in my function. So y is also f of x. It's actually the same, remember? So it's not going to be much difference. So I'm going to set that 3x minus 1 is equal 0. So x is going to equal 1/3. So the x value intercept is going to be at 1/3. So when I sketch the graph, this is going to be my axis. Remember I told you about the axis. So this is going to be x for this case. And this is going to be f of x or y. So we're more familiar with y. So you can assume that as being y as well. This is the same. Okay, so first I'm going to locate my intersection. First, my intersection, the y-intercept, that is going to be at 0, -1. So 0, -1 is going to be somewhere over here. That's my -1. Okay, and then my x-intercept is going to be at 1/3. So this is going to be a coordinate of 1/30. So let's say 1/30 is going to be somewhere right here. So all I have to do is connect these two dots together, and that is going to be our graph. Okay, and of course we can verify whether or not this graph is correct by using the value of the gradient. So as what happened is that as we go towards increasing value of x, so my graph is actually going up. So yes, it's actually an increasing graph. So this must have been the right sketching for the function of f of x equal 3x minus 1. Okay, so that's the first one, A. And now let's have a look at B. So what kind of function is B? I don't want to keep scrolling. So let me look at that for my computer screen. So B is going to be f of x equal -1/4 of x plus 1. So it's still going to be same idea. So we know from here that this is going to be our y-intercept. So the coordinate for the intercept. So that is going to be at 0, 1. So that is going to be our y-intercept. And here, our gradient, m, the value is going to equal -1/4. So we know that what happened is that the graph is going to go down. It's going to be decreasing. And now let's calculate what is going to be the x-intercept. X-intercept occurs when y is equal 0. What is going to be x when y is equal 0? So for this case, it's going to be f of x. So I'm going to set -1/4 of x plus 1 equal 0. So 1/4 for x, so that is going to equal 1. So x is going to equal 4. So that is going to be the value. So the coordinate, so it's going to be at 4 and 4, 0. That's the location. Right, so this is going to be my axis, x here, and f of x for the vertical axis. So let's plot the coordinates. So 0, 1, and let's say it's going to be somewhere up here, and 4, 0 is going to be somewhere down here. So this is going to be a 1 and this is going to be a 4. And all I have to do is connect these two dots together. And there goes my graph of -1/4 of x plus 1. So your graph doesn't have to be exactly like very accurate, no. But it just have to have the features that we needed to intercept, both of them. And then we're fine, we're good to go. Okay, so that's why it's called as a sketching. Right, next example. So I have a quadratic function of f of x equals negative 2x squared minus 4. So we know that when we have a quadratic function, you're required to have a minimum or maximum as well as the intercepts. Like mostly it's going to be y-intercepts, but you have to check as well if the y-intercepts are, the y-intercept actually exists. So first what I'm going to do is I identify here, so the fact that my a value is going to equal negative of 2. So when your a value is equal negative of 2, so what happened is that there is going to be a maximum value because your graph is going to look like this. Okay, so it's going to be a sideways graph. Right, so now let's start calculating for the maximum value. We're going to use the formula that I've shown you before. So for the x coordinate, it's going to be negative b over 2a. So be careful, and we know that b is going to be the coefficient of x to the power of 1, but for this case, so there is no coefficient of x to the power of 1, so for which what happened is that b is equal 0. So that is why, so when I do the calculation here, so I'm going to have 0 over 2, so multiplied by negative 2, so that is going to be a 0. So we know that whatever that is being divided by 0 divided by anything would have been a 0. And for the case of the y coordinates, so I'm going to have to find y, so that is going to be f of negative b over 2a, which is going to be f of 0 for this case, so it is going to be negative of 4. Right, so coordinate is going to be at 0, negative of 4, so that is going to be our intercept. So it's going to be our maximum value, and it's going to be our intercept as well. So this is going to be x, and this is going to be our f of x axis. So 0, negative 4 is going to be somewhere over here. So let's see, this is going to be my negative of 4. So when I sketch this, it is going to be symmetric over here because this is going to be the intercept as well. So does it touch the x-axis? No, it doesn't touch the x-axis. So that is why I would have no, what do you call that? You wouldn't have any x-intercept. Okay, so that's how the graph is supposed to look like. Now let's proceed to D. So for D, so what is my quadratic function for D? So let me look at the screen so that I don't scroll up and down too much and make you dizzy. So I have a function of quadratic again, so which is given by x squared plus 4x plus 3. So here, this is going to be the case that I have my a value is equal 1. So this is a 1 value right here. It's not 0, it's a 1. Okay, so I'm going to do the same calculation. First, I'm going to find, for this case, it's going to be a small graph. So I'm going to need to find a minimum value. So for the x coordinate is going to be negative b over 2a, which for this case is going to be 4 over negative 4 over 2 multiplied by 1. So negative 4 over 2, that is going to equal negative of 2. So I'm going to find f of negative 2 for y coordinate. So I'm going to have negative 2 to the power of 2. So plus 4 multiplied by negative of 2 and plus 3. So here I'm going to have 4 minus 8 plus 3, which I'll end up with negative 4 plus 3. That is going to equal negative of 1. So where is going to be my minimum value? So my minimum value is going to be at negative 2, negative 1. So do we have the intercepts? Okay, so the thing about quadratic function is that, so the c, remember, we have c for linear as well. So c for linear and quadratic is actually the same thing. So they actually represent the y-intercept. And for this case, we know that with the y-intercept, so let me put it over here. So the minimum value is going to be this. So the y-intercept, so that is going to be at this value of y, so which is going to be 0, 3. So if I were to sketch, so it's going to look like roughly like this. Again, so there's going to be x, and this axis is going to be f of x according to the function given. Where's my minimum value? Negative 2, negative 1. Let's say this is going to be negative 2, and somewhere over here negative 1. Okay, so my graph is going to look somehow, oh, that looks hideous, somehow like this. and where does it touch? This is going to be a value of 3. So does it have x-intercept? Yes, the answer is for this case, we do have intercept because x-intercept, because your graph is going to touch at these 2 points right there. So how do we find those 2 points? So this point is right on the x-axis, so those are going to be the values. So when y is equal 0, so what is going to be the value of x when y is equal 0? So I'm going to set the whole thing equal 0. So x squared plus 4x plus 3 equal 0. And when I factorize this, I will get x plus 3 multiplied by x plus 1 equals 0, for which my values are x equal -3 and x is equal -1. So this is going to be a -1, and this point over here is going to be -3. So those are going to be my x-intercept. But for your kids, of course, like put it together nicely and prettily. So do not do it the way I did it. So I'm in a rush. Okay, so it's going to be -1 and -3 for the intercept. So you have to sort of like figure it out first from the x, from the minimum or maximum point and the y-intercept, and based on the sketching, then only we can figure out whether or not like you're gonna have x-intercept. Or usually, if you factorize this function, you set this whole thing equals 0, so this whole thing right here. And if you get a real number, meaning that the intercept actually existed, but if you get a complex number, so meaning that there will be no x-intercept. That is the formula for that, the rule. Okay, so now let's proceed to E. So what kind of function are we going to see for E? So we are past linear and quadratic. So I guess it's going to be, what do you call that? A cubic function. Yes. So I have a cubic function of f of x is going to equal x cubed plus 8. Okay, so remember, for the case of cubic, we have two shapes according to whether the value of a is positive or negative. Now remember that when we learn trigonometry, we have sort of like quadrants. So this is quadrant number 1, quadrant number 2, so quadrant, so that's not a 2, that looks like a 3 to me. So that's quadrant number 2, this is quadrant number 3, and this is quadrant number 4. Like, how do I actually memorize this? I memorize the fact that when you have a cubic function, it actually comes from from quadrant 1 and 3. And for the case of like a less than 0, it's going to be quadrant 2 and also 4. So that is roughly how the shape looks like. Okay, so hopefully that's helpful for you to memorize that as well. Okay, first of all, so here I figured that my a value, so that is going to equal 1. So my a value is greater than 0. So my graph is going to look like this. It comes from the first quadrant towards the third quadrant. And what do you need? All you need is going to be the x and also the y-intercept, if there's any. So y-intercept is definitely going to be there. Is it definitely? Not really. It might not be there. So according to the cases, so all you have to do is substitute. But like here, y-intercept should be there. We always have a value of c. So remember, when we have a quadratic function, so the general form is going to be ax cubed plus bx squared plus cx plus d. And for this case, so d is going to be our y-intercept. So this is going to be the value when all x are equal 0. So now let's start with the y-intercept. So when x is equal 0, so y is going to equal 8. The coordinate is going to be 0, 8. And then the x-intercept is going to be the value of x when y is equal 0. So meaning that you set the whole thing equal 0. This is our y. So I'm going to have x cubed plus 8 is equal 0. So x is going to equal a cube root of 8. That is going to equal a value of 2. So now let's start sketching this. So this is the idea. So it's going to intercept at 8 somewhere over here. This is going to be a value of 8. And it's going to have an x. Sorry, this is going to be negative though. So this is x cubed is equal to -8. And this is going to be -2. So that's why my graph doesn't make sense. So suppose it's going to go through somewhere over here. So that is going to be -2. So when I sketch this, so this is how the graph is going to look like. So it's going to go from here and touches and looks like that. Okay, so that's roughly how it looks like. And of course it's actually come out of the axis. Let me make it longer a little. So it's going to be x, and this is going to be my function f of x. You just have to capture the shape, you don't have to be exact. And f, so you can have another cubic function, but now it's going to be negative. I have f of x is equal negative x minus 1 to the power of 3. But the idea is still going to be the same. First, I'm going to find the y-intercept. So when x is equal 0, so what happened to the function? So I'm going to have negative 0 minus 1 to the power of 3. So I will get negative 1 to the power of 3 is going to be negative 1, negative, negative. So it's going to be a value of 1. So that is going to be my y-intercept. So y-intercept is going to be at 0, 1. And the x-intercept, on the other hand, will occur when y is equal 0. So I set the whole thing equals 0. So negative x minus 1 cube equals 0. So x minus 1 is equal 0. So x, the value is going to equal 1. So my coordinate is going to be 1, 0. So now let's put axis on that and let's see if it makes sense. Okay, and again, so if you were to expand this, you're going to get negative of x. So meaning that your value of a is going to be less than 0. So if your value is less than 0, so your graph is going to occupy the second and fourth quadrant. So it's going to look like that. So now let's mark the coordinates. So 0, 1 was 0, 1. 0, 1 is going to be somewhere over here. That's my 0, 1. This is x and f of x, and 1, 0 is going to be somewhere over here, so we can see the shape already. So basically it's going to be like this. Okay, so roughly it looks like that. So that is going to be our function of negative of x minus 1 cube. Okay, so I'm going to need another page for next example. So I also have g and h. So what's my g function? Oh, now it's going to be a rational function. So my g, I have a function f of x is equal negative of 1 over x plus 2.